All right, this is lesson 12, systems of linear equations. So there are three methods of solving systems of linear equations. Two of these three, substitution and graphing, will be addressed in this section. Systems of linear equations are two or more equations where the equations share a common answer. So there are three possible outcomes. You can have one solution, that's where the lines intersect, no solution or two parallel lines, or all solutions where you have one line right on top of the other line. So the table below outlines when each of these answers occur, and a solution is an ordered pair. So again, one solution is when the lines intersect at one point. No solution is when they're parallel, and all solutions is when they are the exact same. So solving systems of equations by substitution. The substitution method of solving systems of linear equations involves substituting one equation into the other equation to solve for one of the two variables, usually x or y. The steps to solve a system of equations using substitution are: step 1, solve one of the two equations for one variable. Step 2, substitute the equation from step 1 into the other equation. Step 3, solve the new equation for the isolated variable. And then step 4, substitute the value from step 3 into one of the original equations and solve for the remaining variables. Okay, so if you're using a graphing calculator, you can use the graphing method to solve a system of linear equations by solving both equations for y and letting the calculator graph the lines. You can then use the table or graph to determine the solutions. To use the graph, simply trace the intersection of the two lines. To use the table, find the x value that has the same y values for both equations. All right, so example 1, use substitution to solve the system of equations. So I have y equals 2x and y equals negative 3x plus 5. So since y equals 2x, I want to substitute 2x for y into the second equation. Now you can always substitute negative 3x plus 5 into the equation and you'll get the same answer. So y equals negative 3x plus 5 becomes 2x equals negative 3x plus 5. Now the equation involves only one variable, which we can solve for. So I'm going to go ahead and solve for x. So I'm going to add 3x to both sides, which gives me 5x equals 5, and then divide both sides by 5, which gives me x equals 1. The value of x is 1, therefore we can substitute 1 for x in the first equation to find the value of y. So y equals 2x, or 2 times 1, which equals 2. Therefore, the exact solution of this system of equation is 1, 2. This is the only ordered pair that will work for both equations. Okay. Solving systems of equations by graphing. Find the solution of the following system of equations. If the system has one solution, name it. Y equals x plus 4 and y equals negative x minus 2. Okay, so I've graphed both of these, and you can see that here is the point that they intersect. So graph the two equations. The graph shows that the lines intersect at one point, therefore there is one solution. To find the solution, begin at the origin and count the number of units to the intersection. The intersection of the 2 points is negative 3, 1. Therefore, when x equals negative 3 and y equals 1, both of the equations are true. Interpreting solutions of systems of equations. The Keystone exam is designed to ensure that you understand what the solution to a problem represents in terms of the word problem. Therefore, some of the questions on the exam will provide a word problem, the equations that represent the situation, and the solution to the system. The question will ask you what the solution means. So in example 3, Marcia and Greg each buy hot dogs and hamburgers for their friends at a baseball game. Marcia purchased 3 hamburgers and 4 hot dogs and spent $24. Greg spent $30 on 6 hamburgers and 2 hot dogs. The equation below represents the situation. 3x plus 4y equals 24, and 6x plus 2y equals 30. The ordered pair 4, 3 represents the solution to the problem. What does the solution 4, 3 represent? In order to determine what the solution represents, it's important to understand what the question is asking, what is needed to answer the question, and what is provided. For this information, I determine what's missing. So in this problem, the total cost when purchasing items is provided, as well as the quantities of each item purchased. The missing information is actually the cost of the hamburger and the cost of a hot dog. Since the problem explains that 3 and 6 are associated with hamburgers, x represents the price of a hamburger. Similarly, 4 and 2 are associated with hot dogs. Therefore, y represents the price of a hot dog. Finally, hamburgers cost $4 each and hot dogs cost $3 each.